Hello, good morning everyone. Today I would like to share with you the last topic of the Laplace transform, that is the application of the Laplace transform in electrical circuit system. Now let's look at this example. Figure below show the RL circuit with the inductor is 1 Henry and the resistor is 2 ohm, where the switch is switched from the A to B at t equals 0, and then find the current IT through the inductor as a function of time, and then sketch the graph of the IT versus t. So this is the circuit. Okay, this is the circuit. You have the source of 4 volts, and this is the inductor value and the resistor value. Okay, so first of all, you can use the Kirchhoff voltage law, okay, to solve this question. So from here, you know that the voltage drop across the inductor is plus with the voltage drop across the resistor, and then equivalent to the source. So this is the this is the voltage across of the inductor. That is the L for the inductor is L dit over dt, plus the resistor, that is the it R equal to et. This is the source. So dit over dt, okay, plus with the 2it equal to the source. Source is the what? Just now I said the switch is switched from A to B at t equals 0. Means that from A to B initially is 4, but after that it switched to B. B is nothing, right? You have nothing, okay, at t equals 0. So when you write before this, it means that before t equals 0, t less than 0, you will get 4. After t more than 0, you will get 0. Okay, so this is the source. Okay, after this, you substitute the value. Okay, substitute the value. You get the it is 2. And then Laplace transform of each. Okay, so Laplace transform of dit over dt plus the Laplace transform of the 2it and Laplace transform of this one. Okay, but we will consider the t less than 0 because the Laplace transform is not defined for negative value of t. Okay, so this one from page 114, you have the formula for the Laplace transform of the y prime and Laplace transform of yt. Okay, for differentiation, you can get it in page 114, in which the Laplace transform of y prime t, you will get s ys minus y0, and then Laplace transform of yt, and you will get ys. Okay, so from here you know that the Laplace transform of the I prime t, you will get s is, this one, minus I0. Okay, sis minus I0 plus with 2is equal to 0. Laplace transform of 0, you get 0. So for I0, assuming that the circuit was in steady state for t less than 0, so it brings that the t less than 0, v equal to 4. Okay, just now is v equal to 4, right? V equal to 4 and r equal to 2. So I0 is v over r. So v is 4, r is 2, when you get the I0 is 2. So that's why you substitute the value of I0 equal to 2 here. So sis minus 2, okay, the value of 2 that you obtain from here, and then plus with 2is equals 0. Now you want to collect the is, okay, you have the is here and you is here, so you take out the s and 2 here. So s plus 2 equal to 2, you bring the negative 2 to the right hand side, you get the positive 2. So is equal to 2 over s plus 2. So since you have the is, we need to get the it, because the question asks you to sketch the graph of it, so you need to find the it from the is. So inverse Laplace transform of the is, you will get it. So is is 2 over s plus 2. Now 2 is just a constant. Okay, you take out the 2. So inverse Laplace transform of 1 over s plus 2 from the table. Laplace transform table, you can find that 1 over s plus 2 actually is equivalent to exponent negative 2t. Okay, so for t more than 0, you will have the it is 2. For t less than 0, so for t less than 0, you will have the it equal to 2, and for t more than equal to 0, you will have a 2 exponent negative 2t. Then you plot the graph. Okay. Okay, I share with you again with another example. Example 4.32. Okay, 4.32. The question has this kind of the circuit. Okay, you have this kind of circuit. You have the resistor 4 ohm. Okay, and the capacitor 0.2 farad, and the voltage is source is 10 volt. So for the RC circuit in the figure above, solve the current IT and the voltage VT. Okay, and use the initial condition generators and Laplace transform. So in order to solve this, actually you can transform those in the from, you can change to the frequency domain. Yes, you can change it to the transform to a frequency domain. Okay, so for example, this one you can change to 4 ohm, you can change to 4is. Okay, 4is. First, if you refer to the page 148 in your module, you will find that the resistor is RIS. So similarly, the R in the question is 4, so RIS is 4IS. And the capacitor and the source is RS over, this is the voltage across, voltage across the capacitor is IS over SC. So in your module, page 149, okay, this table also shows that in the time domain, capacitor in time domain is IS over SC. Okay, and the source is V over S. Okay, so I hope you know where I get the formula from. All right. So okay, so you know all about this, the voltage across the capacitor and the source and the resistor in time in frequency domain. So we can write it here now. The 4is plus 5 over SIS equal to 10 over S. Is this one? Okay, now we collect all the RS. You have the 4 plus 5 over S equal to 10 over S. And then RS is 10 over S divided by 4 plus 5 over S. You bring this one to the right hand side. And then you simplify. Okay, you get 10 over 4S plus 5. If you want to convert, or you can, if you want to transform from the time domain, from the frequency domain to time domain, so make sure the S here is single, only one. You cannot have a 2is or 3is or 5is. If you have, then you must divide. Okay, divide with the value you have here. For example, 5s plus 2. So you must divide the s divide by 5. Okay, and then plus 5, so 5 also divide by 5. So now in this case it's 4s plus 5, so everything divided by the 4. So you get the single s here. Okay, so 2.5 over s plus 5 over 4. So you get the inverse Laplace transform of the IT is this one. You take out the 5 over 2 because that is the constant only. So you check it from the Laplace transform table, you get the exponent negative 5 over 4 TUT. Okay, and then you apply. Okay, once you get the IS, and then you transform to the IT. Okay, so this one again is from the page 148. Okay, from page 148, you have the capacitor in frequency domain. There is a Vs equal to Is over Sc plus V over S, right? So we will use this one. Okay, so this is the formula. that I showed you just now. Then the IS, this is the IS we found it just now. And the SC. Okay, SC just now is what? SC, you see here? IS over SC. The C is 0.2. So you get 5 IS over 5. 5 IS over S. Okay, so you got the S over 5. Because IS is the top one. You have substitute it. And then V0 over S is 10 over S. Okay, you simplify it. And then from the Vs, you get the Vt. You inverse Laplace transform, you get the Vt here. Okay, you get the Vt. Okay, how to get the Vt? This is the procedure. So this part, we can use the partial fraction expansion. So 25 over 2s, s plus 5 over 4. So you can use the partial fraction. So you use the a and b. You use the a and b. Okay, from here you find the a. Okay, you get the a is 20. Okay, you get the a is 20. Okay, you assume that the s is 0. You assume s is 0, so 25 equal to a, or multiply with the 5 over 4. So you get a equal to 20, and then you assume s equal to minus 5 over 4 for b. So for the b, you get negative 10. Okay, this is quite common to you, right? I assume that all of you know how to find the using the partial fraction expansion. So you get the a is 20, b is negative 10. Okay. So now you have what? So once you substitute the value a and b, you get this one. Okay. This is the value of the a and value of the b. Okay, and substitute into the Vt. So inverse Laplace transform. So this one you get 10. Okay, this one should be the 10 over s minus 10. Okay, no. 20 over s. Okay, 20 over s, you just left 10 over s. So 10 over s plus 10 over s, you still have 20 over s minus 10 s plus 5 over s. So you at the end, you have the inverse Laplace transform of 20 over s, you get 20 ut. And then minus 10 over s plus 5 over 4. So 10 is a constant. So you have exponent negative 5 over 4 ut. So this is how you solve the question. Okay, class, that's all. Thank you for watching.